Okay. Today we are going to talk about dividing monomials. So far, we have talked about adding and subtracting monomials and polynomials, and we discovered that when we add, the exponents stay the same. We've talked about multiplying monomials, and we have our two laws of exponents already. The first one, that if we multiply monomials, powers, then that means we are going to add their exponents. We spent lots of time on that last week, especially on Friday. The second law was that if we were raising something to a power, then we're going to multiply the exponents. And it's important to remember that that's just exponents, right? When we had coefficients, for instance, when we had 5x to the second times 3x to the seventh, we're not going to add 5 and 3 because those aren't exponents. We're going to actually multiply those together like we always have. That's 15. Now I'm going to add these exponents, x to the 9th. And if I had something raised to the power, like 5x to the 4th squared, I don't multiply 5 and 2 because 5 is not an exponent. I'm going to raise it to a power. 5 squared is 25, but x to the 4th, I'll multiply 4 and 2 because those are both exponents. So that becomes 25x to the 8th. So I have 6 examples I'd like to look at today, and we'll add a third rule to our laws of exponents. But let's investigate this. What if I have x to the 5th divided by x to the 2nd? So I want to start with, what does it really mean? Just like we did with multiplication. Well, x to the 5th means x times x times x times x times x. X squared means x times x. Well, any number divided by itself is 1, so those can reduce. And what are we left with? We're left with x to the 3rd divided by 1, which is really just x to the 3rd. Okay? Well, let's look at another example. What if it was a little different? What if I had x to the 3rd over x to the 7th? Okay, well, on the top, that's x times x times x. And on the bottom, we're going to have more. We have 7. 3, 4, 5. Again, any number divided by itself or variable is 1. So these can reduce. That leaves us with a 1 on top. Why? Because any number divided by itself is 1. So we're left with 1 divided by x to the 4th. Now I want you to look at those two and look at the similarities, differences, see if you find any patterns. You may notice already our third rule, that when we, oops, that maybe should be number 3, when we divide powers, what are we going to do with their exponents? We're going to subtract the exponents. So if you look up here, 5 minus 2 is in fact 3. And if you look on the bottom, 7 minus 3 is 4. The question is, where did the power end up? Well, when there were more x's on top, my answer stayed on top. when there are more x's in the bottom, I subtracted and put the result on the bottom. So when we're dividing powers, we're going to subtract the exponents. Let's look at some more interesting problems. There's more going on than just one term divided by another. What if we have a number with that? 10x to the 7th, y to the 3rd, divided by 14, x to the 2nd, y to the 5th. Okay? Well, now again, 10 and 14, these are not exponents, so we don't want to subtract. They're regular numbers. So we're going to reduce them, just like we would any numbers. Well, 10 doesn't divide by 14, but it can reduce. They both divide by 2, so I'm left with 5 over 7. Now, we're going to take each of the variables that have like bases. So I'm going to look at, what about x to the 7th divided by x to the 2nd? All the larger numbers on top, so that's where my answer will go. And 7 minus 2 is 5. Okay, and lastly, we'll look at the y variables. Well, the larger, there are more y's on the bottom, so that's where my answer will go. And 5 minus 3 is 2. Okay. Let's look at another one. Suppose we have negative 8 x to the 4th, y, z to the 8th, all divided by 0.3 x, y to the 3rd, z to the 12th. Whoa, we got more things going on here. Okay, again, we're going to take each term that's like. So let's start with negative 8 divided by 0.3. You could do the arithmetic on the side, but you do have a calculator, that's your tool. Take negative 8 and divide it by 0.3. You'll get a decimal, but we don't want a decimal in our fraction. So on your calculator, remember math, and then number 1 frac. Turn it back into a fraction, and you should get negative 80 over 3. Now, let's look at the x's. X to the 4th divided by x to the 1st. More on top, so it's going to leave my answer here. 4 minus 1 is 3. Now we'll look at the y terms. I have y to the 1st divided by y to the 3rd. It's more on the bottom. 3 minus 1 is 2. And then lastly, we'll look at the z terms. There are more on the bottom. 12 minus 8 is 4. So we have successfully divided those two monomials.